All right, here we go. Example number 3c. So if we take the function 2 minus 2x to the negative 1/3, that's the same thing as saying f of x equals 2 minus 2 over the cube root of x. So if you think about domain and range back in math 10 or whatever, you would know then that you cannot put 0 into the function. The function won't be defined at 0. And that's actually going to come into play when we start talking about slopes as well. So I want to again start off because I want to find critical numbers. I want to know where my slope is 0, where my slope is undefined. So in this example, when we kind of start rolling through it, we're going to see then that there is no place where the slope equals 0. If you were to cross multiply and try and solve for x, it doesn't equal 0 anywhere, but your slope is undefined when you put 0 in. It kind of makes sense that if you don't have a point when x is 0, you can't have a slope when x is 0. So if there's no point at x equals 0, there's no slope at x equals 0, because the function is not increasing or decreasing at that point. So I have one critical number only, and it's going to be 0. I want to know what's happening to the left of 0, what's happening to the right of 0. So if I put in, again, this function here is the x to the 4/3, which is x to the 4th. That's a positive number. And then cubed root will always be positive. So it doesn't matter what number I put in here. My function is increasing from negative infinity to 0 and increasing from 0 to infinity. And again, if you kind of look at the graph of it, from negative infinity to 0, it's increasing. And then from 0 to infinity, it's increasing. But you can't say the function's increasing all the way from negative infinity to infinity, because that's not true, because the function doesn't exist at 0. All right, so that's example 3c, where you have to consider the not a 0 slope, but an undefined slope. In 3d, we're going back to polynomial function gain, x cubed minus 3x. What are the critical numbers? Again, just to help us remember, I want to know where my slope is 0, where the slope is undefined. In this case, there is no undefined slope. It's polynomial. I'm going to deal with where my two slopes are zeros. Again, negative infinity to negative 1 is one region, negative 1 to 1 is a region, and 1 to infinity is my third region. Most important are my slopes positive or negative, and because of my slopes, is my function increasing or decreasing. So once you kind of go through the algebra to figure out the table, we know when your function has a positive slope to negative slope, when your function is going from increasing to decreasing, you are at the top of the curve. So at negative 1, where your slope is 0, that has to be the top of the curve. And decreasing to increasing, so you're going from decreasing to increasing. At positive 1, you're hitting the slope of 0. So at positive 1, you are at a minimum, and you just go back to the original function. F of negative 1 is 2, so your negative 1 is a maximum of 2. F of 1 is negative 2, so your minimum is negative 2. And again, if you did a quick little sketch, you would see here's your cubic function. Function's increasing, decreasing, and increasing. Increase to decrease is a maximum. Decrease to increase is a minimum. So there's your examples 3c and 3d.